Okay, so give this a try. So what is the solubility of calcium sulfate? Calcium sulfate. So sulfate, right, we're looking in this column, and calcium is right here. So calcium sulfate has low solubility. Okay, so pause the video and try this. Copper 2 sulfate. Copper 2 sulfate. So copper 2 sulfate, so sulfate we're looking in the same column. So since copper 2 is not written down here in the low solubility column, it would fall under this most category. So that means that copper 2 sulfate would be high in solubility. Okay, so when you're unsure if it's showing a reaction that has copper 2 sulfate, it doesn't even have to necessarily tell you the state of matter. By using this solubility table, you can then assume that it has high solubility. So there are many kind of outcomes that you'll see when it comes to double displacement reactions. But there's three kind of key pieces of evidence that happen along the way. So you can have one of the following occur. So you can have a precipitate that's formed. So meaning at least one product has low solubility. You might have two products that have low solubility, but as long as if you have one product that has low solubility, that means that you have evidence that the reaction has occurred. Another piece of evidence for this type of reaction is if you see gas bubbles. So gas bubbles usually mean, right, sign of chemical change. Also, if the solution becomes neutral, meaning you have an acid-base reaction, that is also evidence of a chemical change, right? Change in pH. So these are typically double displacement reactions. So let's say we had something nice and simple here. So if we had hydrochloric acid and sodium hydroxide, right? Technically, this is a double displacement reaction. So hydrogen and sodium will swap places. So we'll end up with NaCl and HOH. So HOH, in other words, is water. So HOH can be used. So anytime you're doing a displacement with water, it typically is written as like HOH, but you can change this to H2O. So sodium chloride, this is an example where I don't know the state of matter it is. So we come back to the solubility table. So here's chlorine, and sodium is not down here, which means it's under the most category. So sodium chloride, I would put as a state of AQ. So that being said, I kind of want to make sure that we understand when you're doing displacement reactions with water. Let's go back to a single displacement for a second. Sometimes it's helpful when you are looking at water to write it out as being HOH. So that way when you're doing a replacement, you can see that the H is swapping with the lithium. So I'm sorry, I know we backtracked to single displacement, but this works with double displacement as well. Actually, I'm going to make this a double displacement is what I'm going to do. So lithium chloride is aqueous. So let's say we had lithium chloride and water. You swap them. So what you would end up getting is HCl AQ plus lithium hydroxide. So when you're doing this, HOH can be used in place of water. Sometimes for displacement reactions, it actually makes a whole lot more sense to write it out this way. So lithium hydroxide, if we look on the solubility table, hydroxide, lithium is in group 1. So that has high solubility. Okay, so water really can look at that as being hydrogen and hydroxide. I find it's easier to look at that way. Now, let's say you're doing a reaction and none of these happen. So there's no precipitate made, there's no gas being produced, and it's not an acid-base neutralization. Does that mean the double displacement reaction didn't happen? Well, no, it still happens, but what it means is that there's no evidence of the reaction. So meaning there's nothing visual to see. Like if you're looking at a test tube and you don't have any of these changes happening, you're not able to actually see the evidence. So when you're writing out these reactions, you're always going to swap the elements, but sometimes the question will ask you, well, what is the evidence, the physical evidence of the change? So it's usually one of these three things. If it's not, then you would say that there is no evidence for the change. Okay, so here are some examples. So a precipitate reaction. So this is where you have at least one product that is low in solubility. So for example, here we have calcium chloride and sodium carbonate. We're doing a swap here, double displacement. Calcium carbonate has low solubility. So remember, you check the solubility table for this, and sodium chloride has high solubility. So as long as if you have at least one precipitate, that is an evidence piece for a double displacement reaction. Here we have an example where we have a gas solution. So here we have a double displacement. So we have sodium sulfide and hydrochloric acid. So what's happening here is the sodium is with now chlorine, which is aqueous, and hydrogen sulfide is a gas. Now, this is an example of a gas that I would not expect you to know, okay? But sometimes in the description of the reaction, you are able to get information given to you. So for example, if I were to give you this reaction, I would probably give you a hint that one of the products made is a gas. Well, you know that sodium chloride is not a gas because that's basically salt. So salt doesn't really form gases. But by me telling you that one of the products is a gas, will let you know that it's the other one, of course. So sometimes you'll have questions that will have things in it that you haven't necessarily learned about the state of matter. And it's impossible for us to go through every single compound and molecule that's out there. But if there's something that is missing or you haven't learned about it, I will always give you some clues in the question or in the reaction description to help you out. So here's an example of a neutralization reaction. This is where you have an acid and a base reacting. So just a reminder, how do we know we have an acid? You have hydrogen and the AQ. And of course, a base should have hydroxide in it. So here we have magnesium hydroxide and, and typically with a metal and hydroxide. So here we have magnesium hydroxide and hydrochloric acid. So that makes as a product, I don't know why that 2 is big. So we have magnesium chloride and H2O as a product. So in summary, double displacement reactions will always happen, okay? But there's some, if you're asked to say, well, is there evidence for a reaction or not? The 3 main pieces of evidence that could happen are you have at least one product that is a precipitate, which means it has low solubility. At least one of the products is a gas that's formed, or you have an acid and base reacting to form a neutralization reaction. Okay, and remember, if you're not part of the solution, you're part of the precipitate. See you later for the next one.